Assalamualaikum warahmatullahi taala wabarakatuh. Today we continue with the final of the basic potential flow, which is a so-called doublet. The doublet actually the combine the formed by the combining of two uh, basic flow, which is we combine with the source and sinks in the special way. Uh, as I've shown here, the figure shows the three line for this flow, which is flow from the source goes to the sinks, right? With this case, for a small value, for the small distance of a, which is a approaching to zero, and then which is we have the m approaching to the infinity. Right, look into this figure for more clearance in terms of this form. So from these figures, we know that the source is given by this equation. So the source given by the psi 2, I put it as a psi 2 for the source is psi 2 equal to m divided by 2 pi theta 2, and then 6 is the psi 1, which is equal to minus m divided by 2 pi theta 1. All right, from these figures, from the above figures, we can return this equation for its psi by bringing, we know that we bring the source and since close together. Uh, the distance from the A of the A, which is we have the distance from the A. What is A? Okay, back to these figures. Maybe we can see clearly uh, the A, the distance of A. I take it this in the okay, we can copy this figure first. Let's copy this. Let's, copy this figure. Okay, I put it here. The figures here. The figure here. So, figure here. Right. From this figure, we can see that the psi is a combination of two psi, which is a psi 1 and the psi 2, which is from the sinks and the source. And then from these equations, from this relationship, or from these combinations of psi and sinks, source and sinks, then we can get these equations. All right. These equations, if we look into further, and then we can see that the tangent theta, no, I know that the tangent theta, the for 2 minus psi, because you make a simplification for these equations, because these equations can be written as like this. All right, so you know that this is, you can like written right like this. So we have a 2 pi psi from these equations. This is what we can write. This is 2 pi divided by m. So I divide by m, so I put a minus here. This is minus signs of this equation. So this is equal to, what we can see here is theta. So we have a theta 1 minus theta 2. Right, from this, if we take a tangent of this form of this part, tangent to pi m psi divided by m, so we also tangent in this angle. So what we have, we can write this equation in form of this one, right? So this, from these equations, okay, from these equations, we know that the tangent theta 1, you can see from this figure also, is a tangent theta 1. Okay, this is a tangent theta 1. here. Okay, you can see here. Let's say I put that this is to make you more understand this scenario. So let's say I put this line here, and then this line I name it as line R sine. So therefore, the tangent theta 1, which is the tangent this angle, tangent theta 1, and then we know that the tangent theta 1 actually then r sine theta uh, divided by this distance, right? Divided by this distance. So the given distance is actually the r cos theta minus a. Right, so we have a tangent theta 1, and then the tangent theta 2, similar thing that we done. So we have the r sine theta, which is this is r cos theta. From here to here is r. Okay, from here to here, this is r cos theta. So from r cos theta plus with the source a, so until here, so the theta 2. All right, tangent theta 2 and the tangent theta 1, we know that already the tangent theta 2 and tangent theta 1. Therefore, we substitute these two, tangent theta 2 and tangent theta 1, into this equation 1 as I right here. So substitute to the equations 1 and give us this equation. So the tangent, after you do substitution, and then we make some simplifications, then we get it. The tangent minus 2 pi psi divided by m is equal to 2ar sine theta divided by r squared minus a squared. So as we know that the tangents, and then we bring here the tangents, then what we have now is the arctangent. So the psi can be written as equal to minus m divided by 2 pi tangent arctangent 2ar sine theta divided by r squared. And then we know that the tangent, if approaching to the zero, this is equal to more or less equal to zero. So for the small angle of the theta, we can write the tangent r sine theta. So this tangent for small angle, right, for the small angle of the, when we have a small value of a, the distance is a, that so the value of the tangents, value of the side also become small. So this for the small angle, for for the small value of the distance a, okay, and then for the small angle, so we can write the tangent theta at theta as equal to 0. So approaching to the 0. So that what we can say is that this angle actually uh, the arctangent is actually equal to this value. So therefore, the psi equal to minus m divided by 2 pi 2ar sine theta. We can write this equation in form of this one. So minus m divided by 2 pi 2ar sine theta divided by r squared minus a squared. So this is equal to minus mar sine theta divided by pi r squared a theta. All right, so-called this form is so-called the doublet form, when the source and sinks approaching the one to another, which is a approaching to the zero, while the increase in the strength of m, which is m approaching to the infinity. All right, so since we know that the value of the a now approaching to the zero, so what we have now, r divided by r squared minus a squared equal to 1. This form we can write is actually r divided by r squared minus 0, or we can write like 1 over r as I shown here. All right, because of a approaching to the 0. So now, If we substitute this 1 over r into the above equation, so we substitute this, we put into the this equation, so we have the psi equal to minus m a sine theta divided by pi multiplied, because r over r squared minus r theta is actually the, so this become like this. So now we can say that this m divided by ma divided by pi is equal to the kr. Therefore, we can write these equations as like this. So psi equal to minus k sine theta divided by r, where the k is the ma divided by pi, which is we call it as a strength of the doublet. All right. So for the velocity potential for the doublets, we can write this. We can write the phi equal to k cos theta divided by r. Okay, this is what we have, and then when we plot the line of the constant psi, reveals that the straight line of the doublet are the circle with the origin tangent to the x-axis, as shown in this figure. And then just the source and since are not physically realistic entities, either the neither or the doublet. But however, the doublet can be combined with other basic potential and becomes what we call it the flow around the circular cylinder, which is we will cover in this thing in the next